Hello, my dear children of class 10. Myself, Mr. Bijan Sinha, is going to teach you chemistry. And we'll start with the very first chapter, periodic properties and its variation. So, we will basically learn periodic table. And later on, once we complete this chapter, we'll find out how this chapter is connected to the second chapter, that is chemical bonding. So, let's unveil chemistry. Let's unveil periodic table in front of you. I hope you enjoy this chapter. So as we are going to discuss periodic properties and its variation, we must know what periodic table is. And you all know periodic table is nothing but the arrangement of elements according to the increasing order of their atomic number. So here I have given you the glimpse of first three periods in periodic table. You know that the horizontal rows in the periodic table are known as periods. How many rows are there of these horizontal rows? 7, correct? So there are total of 7 periods, and the vertical columns, they are known as groups. So I told you there are 7 periods and there are 18 groups, though here you see only first group, that is hydrogen, lithium and sodium, the second group beryllium and magnesium, then you can see B and B is written a little far apart. There is group 3 to 12, boron and aluminium comes under the group number 13, carbon and silicon, that comes under the group number 14, whereas nitrogen and phosphorus, they are of 15, oxygen and sulfur, they are of group number 17, fluorine and chlorine, they are 17, they are the halogen, and inert gases, they are the group 18 elements, helium, neon and argon, correct? So this hydrogen, lithium and sodium, this group 1 is known as alkali metals, whereas beryllium, magnesium, calcium, they are known as alkaline earth metals, right? And these two groups are known as S block elements as well. Now boron to fluorine, group number 3 to 17 and 18 also, they are known as P block element. So group number 1 and 2, they are S block. Group number 3 to 12, I haven't told you about them. Group number 3 to 12 is not shown here. Here boron and aluminium, they are group number 13. So 13 to 18, they are P block. 1 to S block, 13 to 18 they are P block, whereas group number 3 to 12 they are known as D block elements. And there is another type of element, they are F block elements, they are from the lanthanide series and the actinide series. Yes, under the periodic table in the 6th and 7th period you find under the symbol La and Ac, correct? Those are lanthanides and actinides, those are known as F block elements, okay? Now, let's see what happens down a group. Now, hydrogen's atomic number is 1. The elements they are arranged according to their increasing order of atomic number. Hydrogen's atomic number 1. So, number of proton is also 1 and number of electron is also 1. Helium, the atomic number is 2. So, 2 protons and 2 electrons, whereas lithium is 3 and so on. We have here 18 elements and 18th element is argon, correct? After that at 19th number we have potassium, whereas at 20th we have calcium. Now in group 1, down a group, hydrogen, lithium, sodium and potassium is there. Their atomic numbers are hydrogen is 1, lithium is 3, sodium is 11 and potassium is 19, right? So the electronic configuration of hydrogen is only 1, lithium is 2, 1 as there are 3 protons and 3 electrons as well. For sodium it is 2, 8, 1, 11 electrons. For calcium 2, 8, 8, 1. So this 1 is always a constant. So down a group, number of shells increases but number of valence electrons remains same. For hydrogen it was only 1 shell. For lithium it was 2 shells. For sodium it was 3 shells. So number of shells they that is keep on increasing. In case the case of potassium there are 4 shells as well. Across a period from left to right, what happens? Nuclear charge increases but outer shell remains the same. That means number of shells remains the same. For hydrogen, the atomic number 1 electron, electronic configuration 1. For helium 2. So there the number of shell is remaining same, only one shell for the first period. For the second period element, two shells, 2,1 for lithium. For beryllium 2,2. For boron 2,3. For carbon 2,4. For nitrogen 2,5, and so on. For the third period, from sodium to argon, there are three shells. So number of shells across a period from left to right, that is same, but what is increasing? The atomic number. Like hydrogen is 1, helium is 2, then 3, 4, 5, 6, 7, 8, 9, 10, and so number of atomic number is increasing, 3 to 12, right? 3 for lithium, 4 for beryllium. So number of proton is being increased. Where does proton stay? Protons stay in the nucleus. So if the number of protons keep on increasing, that result in the increase of nuclear charge. So that is why it is written nuclear charge increases, but outer shell remains the same. So total number of shells is remaining the same. Valence electrons are pulled more towards the nucleus. Now for lithium, say 3 protons are pulling 3 electrons, and for beryllium there are 4 protons are pulling 4 electrons. So where the attraction force will be more? Where there are more number of protons and electrons are attracting each other, correct? That is why it is said that valence electrons are pulled more towards the nucleus. And you know very well, protons are positively charged, electrons are negatively charged, that is why they are pulling. So wherever the electron is at the outermost shell, they are being pulled by the more number of protons. If we go from left to right across a period, for beryllium only 4 protons are pulling the valence electron, but for oxygen total 8 protons are there, oxygen's atomic number is 8. So 6 valence electrons, 2,6. So these 6 electrons are experiencing more of attraction force than those electrons of beryllium. I hope this point is clear to you. Now down a group, as number of shells increases, we just now discussed why down a group number of shells increases. So atomic size increases. You always can consider this number of cells like the number of rooms in your house. So if number of rooms are increasing in your house, the size of the room will increase. Similarly, if number of shells is increasing in an atom, then the size of the atom will increase. So atomic size increases. So metallic character increases. Please understand why it is being said that metallic character increases. What is the definition of metal? Which donate electrons and form a cation. So if the atomic size is increasing, the electron which is at the valence shell in the atom, that is be very far from the nucleus, that is very far from the center if the size is more, right? So atomic radius is also more, that is why the distance from the center to the valence electron is more. So it can easily give away the electron, it can easily become the cation from the neutral atom. That is why their metallic character increases if you go down a group from top to bottom, like from hydrogen, lithium, sodium, potassium, right? Atoms can readily lose electrons, that is what I have discussed. Ionization potential, electron affinity, electronegativity decreases. I will just show you like what are the definitions of ionization potential, electron affinity and electronegativity. But before that, let's see what is happening across a period from left to right. Valence electrons are pulled more towards the nucleus, hence atomic size is decreasing. If the attraction force is more, there will be contraction in size. So the size decreases across a period from left to right. You can compare down a group, what is happening, exactly the opposite is happening across a period from left to right. Okay, metallic character decreases as atomic size decreases. Why does metallic character decreases? Like the tendency of losing the electron will decrease because valence electrons are pulled more towards the nucleus. Atoms gain electron, yes, like say fluorine. Fluorine has 7 valence electron, oxygen has 6 valence electrons. Now, for them to attain stability, to attain the electronic configuration which is stable, that is the complete octet, either they can add up one electron. Like for fluorine, it has 7 valence electrons, so it can just add up one electron. Oxygen can add up or 2 electrons because oxygen has 6 valence electrons. But the opposite, that is removing those 6 or 7 electrons, that is quite like difficult process. More than removing those 6 or 7 electrons, taking 1 or 2 electrons is easier. That is why it is written atoms gain electrons. And see IPEA, that is ionization potential, electron affinity, electronegativity decreases. What is ionization potential? Ionization potential and electron affinity both are amount of energy. Now see, after they both are amount of energy, that part is same. Now it is just the opposite. Energy required, energy released for electron affinity, energy required for an atom to lose an electron. So now what is happening in an atom? The electron is negatively charged and it is being pulled by the positively charged protons. So to remove, to take out that electron from the attraction force of the protons, you need to apply some energy. So that energy is known as ionization potential, energy required for an atom to lose one electron, the valence electron from the outermost shell, right? For definition, you can always consult your textbook. You can write this also using this key phrase. Electron affinity is what? Energy released when an atom gains electron. So ionization potential, energy required, but in the case of electron affinity, energy released when an atom gains an electron. Now, say for hydrogen, it has only one electron. For lithium, it has 3 electrons, 2, 1. Now for sodium, it has 2, 8, 1, that is total 11 electrons. Now, if I want to add up electron, energy will be released, and the energy released will be less if we go down a group. That is why it is written electron affinity decreases. As the distance is also more, so less of energy will be released. But across a period from left to right, electron affinity, ionization potential, both of them, they increases, but down a group they decrease. Now electronegativity is the tendency of attracting electrons. See, electron affinity is the energy released when they are accepting an electron, but in the case of electronegativity, it is the tendency of attracting the electron when combined in a covalent molecule, right? So that's all from periodic table. If you want more reference of, so by now your understanding of periodic properties and its variation should be a little more clear. If you want to understand periodic table in a better way, watch the YouTube videos, those are shared with you all. And after watching those videos and doing your own homework, and please write down whatever you are learning through these all online contents. So once you become confident, please see the questions, those are sent to you, and please write the answers. Okay. So once you complete the chapter periodic properties and its variation, let's see how the second chapter chemical bonding is connected to the first chapter. So here comes chemical bonding in front of you all. I hope you enjoy this also.